In this video, we're going to use this Makerfabs Maduino Zero board to create a GPS tracker with integrated LTE cellular connection. Makerfabs has created this board to be compatible with the Arduino family, in particular the Maduino Zero, so you can use your Arduino development environments to program this board. Let's do a quick tour of this board. In the center you can see the SIM7600 module. This module is really the heart of this board and allows connectivity to GPS satellites in addition to the LTE connection. So on the back of this board there's a SIM card slot which you can insert your SIM card. I'm using a Twilio Super SIM for this SIM card. This SD card is accessible by the Arduino system, and this other SD card is accessible by the SIM7600 module. Here I got the board laid out so you can see all the different components connected to the board. You got the board in the center. It's currently powered through this battery pack. Another option to power the board is through this USB-C port, which is also where you program it. One nice feature is when you are powering this board through this USB-C port, it will charge your battery pack. Over here you have the GPS antenna connector, and you can see the GPS antenna is connected here. And then on this side you have two LTE antennas, a primary and a secondary antenna for the LTE system. So before we look at any hardware or any software, let's talk about the GPS system. So the GPS system consists of a number of satellites that orbit the Earth. As we hold our handheld device like our phone or this GPS tracker, it gets a signal from the GPS satellite, and essentially kind of measuring the distance or the time it takes that signal to get to your handheld. And if you know that time, then that places you somewhere on a sphere that surrounds that satellite. Not very accurate with just one satellite, but if you add two, the intersection of two spheres is a circle, and so you fall somewhere on that circle. And if you continue to add satellites, eventually you get enough data, enough information to accurately pinpoint exactly where you're at. So now that we understand the theory of how it works, we're going to use this card and we're going to detect GPS signals, and it's going to tell us our GPS location, our lat long and our altitude. And we're going to collect that data, periodically, say every 5 or 10 seconds. And then at some interval, we're going to upload that data to a website. And so we can track our location then over some period of time, and we can know where we're at. It doesn't have to always have LTE signal, because we're going to be caching the GPS locations on the SD card that's part of the board. Now typically we don't really care about a board, but we put this board or this project inside of a crate that we're shipping because the contents of the crate is expensive. I want to know where it's at, or we're tracking some piece of industrial equipment or something that can be easily stolen. So why build this ourselves? There's commercially available devices that can do this for you. For example, here are a couple of GPS trackers. Some of them plug directly into kind of different ports that are a part of your vehicle. Some of them are kind of standalone units that you can attach or stick into things. But all of them have an equipment price, which isn't so bad. So that's kind of equivalent to what the board you'll see that I purchased costs. But the kicker for me is this monthly fee. I already have a website. I'm a web developer. I don't want to pay a service fee every month, for the GPS tracker to talk to or send data to. I want that to be my own host. I want to host that myself. Before we get going and looking at the software and the code, let's look what the manufacturers provided us. The manufacturer is called Makerfabs, and it's a Maduino Zero 4G LTE, and it's equivalent to the Arduino Zero. So when we start to set up our board, that's important to keep in mind. This website contains a lot of information, and so I'm not going to kind of cover it in detail, but you can go through here and you can scroll through here. One of the most important parts is probably this piece, because you have to decide which board you're going to get depending on where you live. So in North America, I get the A-H board, which is up here. You can select that, your frequency band, and you can get the board that will work in your area. The other thing I'll point out is there's a number of links, and you want to follow the links because there's a lot of information here. There's YouTube videos on people that have used this board before, but down here, there's two links that are kind of important. This one is a GitHub page, and I've loaded that GitHub page here. And you can see kind of the content of the GitHub page. It has some example code. Definitely go through all those. But one of the things that I will show you here on this GitHub page is, it repeats a lot of information, but this document right here, this is a PDF, and it contains all of the commands that you can send to this SIM7600 module. Think of this SIM7600 module as a black box, and you're going to connect to the black box using a serial port, and you're going to send commands into that serial port, and then you're going to look at the responses that you get on that serial port. And so this command set, they're called AT commands. Historically, that's how you talk to modems, using AT commands. But if you download this and take a look at it, you're going to see quite a few AT commands, a lot more than what we're going to use. But this document, you can dig into this document and you can find all the commands. You can find the information on everything. So if you look at any one command, you can dig into it and see what it does, the description, the format, if it takes any inputs, what do they look like, what's the response mean, and it has all of that information here. The other link that you're going to find is the wiki page, and I've loaded the wiki page here for us, and we can look at this. And again, there's repetitive information, but then there's also new information down here. So one of the new things that you'll see is you're going to see a section on how to use the AT commands. And they're doing it using the Arduino IDE. And so, all their examples are using that IDE. We're going to use Platform IO, but it's pretty similar. And so you can kind of get the feel for this. You look at their examples. And so what you can see is you can see the commands, and then you can see kind of the responses. They give you pictures of the responses. So for example, here's how you get a GPS lat long. You start a session, you ask for the lat long, or the information, and then you end your session. And so this command right here, you can see its response. It's a string, and embedded in that string there's lat and there's long in here, and there's your altitude also. And so programmatically, what we're going to do is we're going to take this set of AT commands to get a GPS location, and we're going to automate that and say we'll send those commands, I don't know, let's say every 5 seconds. And so we can get our GPS location every 5 seconds, and we can cache that to the SD card. And then later on, we can wake up, periodically and send all of that cached data to a website, using HTTP posts. And so that's what we're going to do. We're going to automate this thing using some HTTP commands. One of the things that we'll need to do before we get started here is on the back of this board, you can see a SIM card slot. So before we can get this thing connected to an LTE network, we have to place a SIM card, an active SIM card in here. There's a lot of providers for SIM cards. I'm using Twilio. I love their service. I use them for other applications that I have, and so I just continue to use them. They're very inexpensive. They're good at what they do. I use something called their Super SIM, and it's directly for IoT devices, which is what this is. And essentially, you pay $3 for them to send you a SIM card, and then after that, it's a pay-per-use. And I forgot what the expense is, but it's super affordable. One of the things we'll need here is their network name, and so it's called Super, and we'll be using this in our code in a little bit. Speaking of code, I've already uploaded all the code for this project to GitHub, and so if for some reason I'm going too fast or the font's too small, or for whatever reason you want to download this and upload it, install it on your own hardware, this is where you can get it at. I mentioned earlier that I'm going to use Platform IO for the development environment, and getting started with Platform IO is not what I'm going to cover in this video. So there are plenty of tutorials on getting started with Platform IO, and so you can click on, for example, this link and follow that tutorial. It'll get you going with Platform IO. One of the things I like about Platform IO is it has a registry of all these different kind of packages that you can extend your project with. This is code that you don't have to write, and as an example that we're going to be using in this project is I'm going to be using this Arduino library to read and write to SD cards. And so these libraries, these packages that you can find, they tell you how to install them and kind of use them and everything. So super nice libraries and a way to extend your project. Here we are in Visual Studio Code, and I have the Platform IO extension installed. I already have the code here, so let's do a quick code review. The first thing I always like to do is when you are using Platform IO, you want to look at this .ini file. This INI file tells Platform IO what hardware you're using. So this is the board that we're programming against. So it's the Maduino Zero board. And again, I talked about using the SD library, and so we added that extension in here so that we can use that extension. So that's the important thing about Platform IO. It kind of really sets the board, and it adds any kind of libraries or any dependencies that you'll be using. So the next bit of code that we're going to cover is we're going to start to look at some of the C++ classes. Again, object-oriented programming is, in my opinion, it's the way to go. It allows you to encapsulate some functions and features and put them into classes. And so the first class I want to look at here is this file helper class. I want to make the font kind of as big as we can here so it's easier to see in the video. But this file helper class essentially has a number of helper functions. The SD card library that we imported, has basic writes and reads and does this file exist. But some more complex things you have to kind of build yourself, and that's what we're doing here. And so there's ability to kind of remove files or delete files. I can quickly append a string to a file. We'll talk about this one in a second, but essentially I can copy a source file to a destination file, but skip like the first X number of bytes. This is kind of a way that I can kind of debug things a little bit. I can print the first X number of lines in a file and see what they look like. And then lastly, there's a function to strip the number, let's say the top 5 lines from a file, and I get those lines in return in a string. So let's look at the code now that we've kind of looked at the header here. And so I'm going to go to the bottom here first because I think these are a little easier functions to get through. The first one's just remove. Pretty simple. Takes a file name. Then I'm using the SD library to kind of really do the hard work here. Same thing with the append. So append takes the file name and whatever line I want to append. And again, I'm using the SD card library to open that for read or for write, and then if I do get a handle to it and I've got it open, I seek to the end and then I append that line to the end and I close the file. Again, pretty easy to go here. We'll look at the copy function next. A little bit more complex, but not that bad. There's 3 parameters: a source, a destination, and the number of files or number of bytes that I want to skip. And again, I'm using the SD card library just to, kind of do all the lower level lifting. This function returns a bool, but one of the things that I need is sometimes I need an error. And so there is if you look back at the header, there is a public string where I can put an error message into. And so here on this copy, I use the SD library to open the source for reading. And again, anytime I run into any kind of situation where I have to error, I put the error in there and I return false. If the destination file already exists, I delete it, and then I open the destination file for writing. And again, if I can't open it, I provide the error. One of the things that's important is when you're doing reading and writing to SD cards, if you're going to do it one character or 1 byte at a time, it's very slow. So it's better to kind of blast a buffer over there, and then that's a lot faster. So I'm using a buffer size of 1 kilobyte, so 1024 bytes. And so I'm using this buffer for essentially all the writing. So I'll write that many bytes at once. So I do a little bit of calculation to figure out how many buffers that I need. I skip the characters that are in the parameter that was sent in, and then here's where the copying happens. And so I already calculated how many buffers I'm going to have to write. And so essentially I'm going to go through and I'm going to read a buffer, and that fills this array full of bytes, and then I write that buffer to the destination file. And the only trickery here is the last buffer isn't necessarily a full buffer, not 1024 bytes, but it may only be a partial buffer. So I have to kind of keep that in mind. And then the last thing I do is I close both handles to the file. So the last function we're going to cover is this strip lines from the top function. And this is very kind of specific to our application. Essentially, what we're doing is we're caching the GPS data, the location data, one line at a time. We're appending it to a file that we're writing to the SD card. And that way we don't have to run the LTE radio all the time. We can conserve battery. And then we can wake the LTE radio up at a certain interval and grab, say, 10 lines or 5 lines or whatever it is, and then we can send them all at once in bulk. And so that's what this is going to do. It takes the file name, it takes the number of lines to strip from the top. It uses the SD card library again. I open the file. So here's where the real stripping off the top lines goes. So for this GPS file that I have open, as long as I have data and I haven't got the number of lines yet, I keep reading a character. And so I keep appending this character to the current line, and I keep incrementing my skip. So essentially I'm tracking how many characters I've read so far. And that's going to be important later on in this function. We'll look at that. We're using that in a bit. New lines are defined by the end of line character. So if the current character is the end of line character, well, then I trim this current line that we have. I do a little bit of manipulation here. This is application specific because I want to make sure I have a valid GPS line. If this line is garbage and it doesn't have the kind of the prefix that I'm looking for, I ignore this line. But if I do find my prefix, then what I'm doing is I add this current line to my total lines that I have that I'm keeping, and I add a new line character at the end, and then I increment my number of lines. And then I set the current line to equal to empty string again, and I repeat this until I find the next valid line. And so this while loop is reading one character at a time. I keep concatenating it to my current line. It validates that I have a valid line, and then it adds it to my total lines. And so up here is where my total lines are. Eventually, this is the thing that I'm going to return at the very end. So once I've got my number of lines that I've asked for, here's where I get to, here's where I'm doing the other important part. Remember, I'm taking, say, 10 lines from the top of the file, and then when I'm done, I'm expecting that file no longer has those 10 lines. And so here's where I'm removing the lines. So this removal process is a little janky, but it is what it is. So if I asked for 10 lines and I found 10 lines, that means there's probably still data left in the file. And so what I have to do here is I copy the file to a temporary file, skipping the number of bytes that I've read. And remember, I track the number of bytes I read up here. And then I copy that file back to the original file so it no longer has it. So the first step is I copy to a temp file and I do the skip. And so now this temp file has everything but the 10 lines that I pulled off. And then I have to copy that file back to my original file name. And so again, a bit janky, but it works. If for some reason, I asked for 10 lines, but I only have 5, that means I read to the end of the file. And so I don't really have to do anything special. That's a little easier. I can just remove the file. And then when I'm all done, I return the number of lines. So again, it's a little bit more complex of a file, or complex of a function. That's why there's a wrapper around this so that I can use this a little bit later. All right, the next C++ class that I'm going to cover is the AT command class. This class encapsulates sending the AT commands. Again, we talked about how that SIM7600 module, if you look at it as a black box, you're going to have a serial port, you're going to send AT commands to it, and you're going to look at the response. And so this kind of encapsulates that sending and that response look at. So here's the AT command class itself. It has a constructor. You can pass in a flag, whether you want to debug or not. If you're in debug mode, then it kind of is a little bit more verbose, and you can see kind of console out a little bit more. So the send command and wait function, again, most of the time I want to send a command to the module and I wait for the desired response. The desired response might be the word okay, it might be something else, but I'm going to wait for that for this timeout period. And so that's what this does, and we'll see the code for that in a second. And then the other case is I just want to send generic data to the module, and I want whatever it sends back. And so that's kind of a generic send data. Let's look at how these are implemented here. So first of all, we see the constructor at the very top. It takes the bool and it sets the flag. There's a private variable down here that kind of lets the class know that it's in debug mode. And we'll see this being used a little bit later on. Here's the send command and wait. It takes a command, and this defaults to the overloaded one that takes 3 parameters. But here the default parameters are, it's waiting for an OK, and it's going to wait for 1 second. So I use this one a lot. That way I don't have to provide the other options here. Most of the commands, it follows this pattern. We're looking for OK. Sometimes it doesn't. And so this kind of more verbose one is used some other times. So if we look at the send command and wait that has 3 parameters, again, I'm waiting. I want to wait for some desired response. Maybe it's OK. And there's a timeout period of like maybe a second or something. So here's a Boolean. I track this, whether or not I'm getting the desired response in the response string. There is a last command response string, and that's in the header. It's a public member, so you can get access to this anywhere you use this, and I can look at the last response. So I set it to an empty string first. Here's where I send the command over this serial port. So now the module has seen the command, and now I'm just going to start to wait and read data that the module is sending back. So here's kind of the standard loop. I take a current time snapshot, and then I'm waiting for the timeout. So while I haven't timed out and I don't have my response, what I'm going to do is sit inside this loop, and I'm going to continue to just read from the serial port from the module. And I'm reading 1 character at a time, and I just keep adding it to my last command. Once I get some characters, I do inspect them, and I see if the last command response, does it contain my desired response? If it does, I can set that flag. And once it does, I'm pretty good. I'm going to go ahead and exit this main loop. The only thing I do is there is one final bit where maybe there's a few more characters that are after that response that I just want to read them as one full kind of packet. And so I do one final while loop until there's nothing left on the serial port coming back out of the module, and I just keep adding those to the response here. But at this point I've already set the flag. Is it true or not? Because I know this was a command, I'm doing a little bit of work here to kind of strip out some things. I replace the command itself with an empty string, so I strip it out. If I did find a desired response, I strip that out too. And then lastly, I trim out any kind of end of line characters or any white space at all. So here's where you can see if I'm in debug mode, I print this to the console, and that way I can see the command that was issued and the response. And then I return whether or not I found the response. And so that's really kind of the first set of commands, the send command and wait. The send data is a little less work because I'm just sending the data. I really don't have to wait for a response. There is a standard timeout of 1 second here, but if you look, this is very similar to the code above. So this is a little bit of hackery to essentially send hex code 1A to the console if I'm doing kind of typing into the console directly. But you can kind of ignore this for most of the parts. Really what I do is I take the data that I wanted and I send it to the console, and then here I'm reading all the way up to the timeout. I read all the responses. Once I have the response, if I'm in debug mode, I print it back out to the console out so I can see the serial console, and then I return the response. So pretty simple wrapper around sending commands and kind of parsing the responses. The next bit of code is a class called hardware, and this encapsulates initializing the hardware, turning the module, the SIM7600 module on or turning it off, configuring that module, and we're going to see some of the functions that we use here for this. So here's the header file for this class. There are a couple of strings that we make available, and as we're initializing this header, you're going to see we're going to use the AT command class we already covered, this command helper. We're going to send commands. Some of the commands that we're going to send, they're going to allow us to kind of interrogate the hardware a little bit, find out who the manufacturer is, the model number, and for kind of the SIM kind of card, I want to have this identifier, this IMEI identifier, and I can get this as part of the initialization. There's a couple of initializations functions here, initializing the hardware itself, the SD card, turn the module, or find out if the module is on. Is the SIM7600 module, is it on or is it off? Turning the module on, turning it off, configuring the module. And the last two functions here are, as the module is writing and giving output, and we also have the other console that we're using, they have to be able to talk to each other. So this kind of sends bytes from one console to the other, and we'll see that in detail in a second. So if we look at the implementation here, at the very top, there is a constructor, and it takes an instance of the AT command class, which we already covered. And I just set the private member. I initialize that private member. And we're going to use that a lot to send commands to the module, the SIM7600 module. Here's where I initialize the hardware itself. And so I'm initializing the two serial ports. This is the console out. This is the USB port and what we program it through, but it also is the console out so I can see what is being written. This is the serial port that is from the hardware to the SIM7600 module. So if I want to send something to the module itself, I use this serial port. It's a kind of an Arduino system, so there's a couple of pins that we have to have. We configure them as outputs, and then I start to set those pins. I'm setting this pin low, for example, and I'm setting this pin low also. And a couple of delays as you do this, because some of the hardware needs to have those delays so that it can get set up and initialized. Here's where I initialize the SD card, and again I use the SD card library to do that. And if it initializes successfully, I return true. If it doesn't, I return false. So here's where I can test and see if the SIM7600 module is on. And I do that just by simply using my command helper, and I send an AT command. And if I get the response of OK, then I know it's on. And then I put this in a little loop here because I try it like 5 times, especially right when you power on a board, and we're putting the power on this thing. It takes maybe 5 times for it to kind of really test it. So I just loop 5 times, and if I do ever get a response that says OK to that command, then I return true. Otherwise, eventually I return false. The next two functions, again, are to kind of power on the module. So the module is connected up to this pin, which is defined at the very top. So pin number 5. And here's where I turn the module on and I turn it off. So to turn it off, first of all, I test it if it's on. If it is on, I just set the pins, I set it low eventually. And then I know it's off, and I return, and I retest it and make sure it's off, and I return that. Here's where I turn the module on, same kind of thing, but the opposite direction. So it's high here, now it's low, and so vice versa. And again, I return if the module's on. So the module itself has some configurations that kind of you want to set, and I also want to send some commands to kind of figure out what kind of, who's the manufacturer of this module, what's the version, what's the model number, and things like that. So here's where I'm kind of configuring the module, and I send some commands, and I wait till I get responses. And so one of the commands that I send, this sets the error condition kind of in verbose. So if I'm debugging, I can kind of see more information. Here's where I get the manufacturer. So this command, AT plus CGMI, I send that over. I wait for an OK response, and then my response will be the manufacturer. And so I'm setting that that string that's publicly available on this class to the manufacturer value. I do the same thing here. This is requesting the model number, And so we'll see this in a little bit, but I set the model number then. And then lastly, I get the serial number for, this is essentially the IMEI number by sending this command. There's a couple of commands that are kind of useful sometimes when you're debugging, but I've got them kind of commented out here. Finally, I have some configuration for kind of the radio and the GPS just to make sure everything's set up. In particular, this last command is where I set the APN value. Remember, Twilio has the name called super, and so this is where you set the APN value for this module that you're using for your SIM card. If this all happens, then I return true. Otherwise, I return false. And the last two functions, again, just kind of coordinate the one serial port output to the other serial port input. So here, for example, if there's output available from the module, this is the module, then I read that output and I write it to the USB serial port. And so when the module's talking, that way I can see it on console out. So this is essentially console out. Same thing here in the opposite direction. So when there's USB input available, so if I see stuff on the USB, I read it one character at a time, and I'm going to send it down here. I'm going to send it as a command to the actual module itself. And so whatever I'm reading as you're typing it in onto the console out, and you're doing some manual type work, it'll wait for an end of line character. Once it sees the end of line character, then it'll send it to the console, the module itself. So far we've reviewed the file helper class, the AT command, the hardware, and we're going to look at the GPS class right now. The GPS class is kind of encapsulates the feature about getting our current location. And so it's a pretty simple class. It has really kind of one method. So I use this method, but if you ever want to use and set the parameters yourself, you can use the overloaded current location. And then this results in either a true or false, did I get a new location or not? And if I got a new location, the location of data will be stored in this string. And so that's kind of at a high level how it works. The constructor here takes the command helper that we talked about earlier, so it can send commands to the module. So if we look at the implementation here, here you can see the constructor, the command helper. I'm just setting this private variable that is part of the module, so I can get access to the command helper. Here's the first get location, which just kind of defers to the overloaded one with some default parameters. And so the default parameter has a timeout of 60 seconds. Sometimes, especially right when you turn the GPS module on, it takes a bit of time to lock onto a satellite or to get enough satellites to get a lock and get your location data. And so providing a kind of a bigger number here is okay. And then whether or not you're going to kind of keep the session open. And so we'll see this in a second here, how that's used. This is the return value. So I'm keeping track of whether or not I got new data value. And we're going to see this at the very end. I return this thing at the very end. And so kind of tracking whether or not I found data. One of the first things I'm going to do is I'm going to use the command helper, and I'm going to see if there's a current GPS session open. So if I send this command and I look at the response of this command and the response has this thing, then that means that there isn't a GPS session open. And so what I want to do is I want to send another command to open the GPS session. And so that's what I'm doing here. And so once I send this command, if I get an OK response, then I'll be down in this section down here. If it doesn't create a GPS session, I'm going to return my false. So once I have a session open, then I'm going to enter this while loop, and I'm going to stay in this while loop till I time out. And again, the default timeout is 60 seconds here. And so I'll stay in this loop until I've reached my 60 seconds or until I break out. And we'll look at this in a second. So I'm going to send a command, the AT CGPS info command. And that's really asking the module, hey, give me my location at this time. If the GPS hasn't really locked on, then there's a possibility you might get a couple of different responses, like an empty string, or you might just get a string that has a bunch of commas in it. And if you do this, if you get that as a response, then what I do is I know what there's no GPS lock. I kind of delay for 2 seconds here to give the module time to get a lock, and then I continue, which bumps me back up to the top of this, and I try that again. And I keep trying. I send this again until I finally get data or I've timed out. Now, if I do get data, the data that I'm getting has multiple strings or multiple lines. And so what I'm doing here is I'm just taking the lines that I find and I'm parsing out the line that I want. And I do a trimming of it. And this is the data that I'm saving. I set that I have a refresh data bit to true. And I break out early. So I don't have to spend 60 seconds in here, but the most I'll spend in here is 60 seconds. If I get to this point, the only thing to do is close the session if you pass that in. If you close this session, then you have to open another session the next time you want GPS point. And so there are some advantages and disadvantages of that. One disadvantage is it takes time to get a lock every time. So depending on if it's a hot start or a cold start, it could take some time. So my default value here is false. I'm not closing the session. I just leave it open. And I'm using a little bit more battery on this one, but it's quicker to get my lock. And I do this mostly right now because in debug mode, I'm debugging this. I want to get the point quicker. I don't want to wait for it to get the lock every time. So that's where I can keep the session open, and then I return whether I got it. And so that's really the GPS module. I ask for a current location, and essentially I put it and I store the data here in location data. All right, so the final class to review here before we look at the main CPP function is this HTTP helper class. And again, this is meant to encapsulate, the sending of data to the website. And so you can see in the constructor, again, we're going to use the command helper class that we already kind of covered. And then it really has one method here as a HTTP. I'm going to use this to post data. So I'm HTTP posting the data, and I'm going to kind of build that HTTP session, and we'll see that in the code. But this thing takes a URL. It takes the content that I'm going to send, and then it takes the content type. And we'll see all of that in a second. So we dig into this thing a little bit here. The constructor, again, takes the command helper, and I'm just kind of storing it in that private variable so I can use it in the post class here. The post class is really not that long at all. There are a lot of commands that you send to send HTTP data over to a URL, but it's really kind of all in the helper, so we're using the helper. And so what we're seeing here is I have a bit that I'm going to track, whether or not I successfully sent it or not, and I return that bit at the end. And I do set it at the point where I know that I've sent the data for sure. And so the first command is I send this HTTP term, so terminate command. So if there was an open HTTP session, I'm going to terminate that session. This command is just to ensure that if for some reason there was an old stray HTTP session open, it's done. So I kill that session. Otherwise, I don't really quite know where I ended up in the string of commands that I have to send. So this is just to making sure that I'm always starting a new session every single time. Here's where I start the new session. So I initialize a new HTTP session, send in this command. If I find the response is okay, then I stay inside this if loop. And then the next command is I send the URL that I'm going to want to post to. So this URL, you pass it in through as a parameter. And so now I've told the module I've started a new session, and here's the URL that we're going to use for this HTTP session. Next thing I'm going to do is I'm going to use the HTTP para command again and tell it the content type.
And again, the content type, maybe it's text or maybe it's form data or JSON. And so I'm going to tell it the content type that I'm sending. If this is successful and I get the OK, the next command I'm going to do is I'm going to tell it that I'm going to start sending it data, and I'm going to send it this many bytes. So I'm sending HTTP data. Here's the number of bytes that I'm going to send to you, and I'm going to send this in the next 5 seconds, and that's what you should be expecting. So here's the command right here that I'm sending over to the console. And again, this is a send and await, but I'm not using the standard. I'm waiting for the OK. I'm actually waiting for it to say download. So once I see it says download, then I can dump the data, the content actually onto the module. And here's where I use my other, this command helper had a send data command. And so I'm just dumping that content, and I'm throwing an extra couple of carriage return line feeds on the end of there. Once I send the data, and this all happens within 5 seconds here, I send this action method, which tells the module that I want to do HTTP post. Once it knows that it's going to post the data, it has everything it needs to do to actually send it. So you told it the URL, you told it what the content type is, you told it how many bytes, you sent the bytes to it. Now the module knows it's posting, and it will actually do the work. So right after line 26, there's a bit of a pause here. And this is where it's actually it's turning on the radio, and it's sending the data over the LTE connection. And so there's a timeout here of kind of large, about 10 seconds. So far, this has always worked for me, 10 seconds. You may have to adjust this depending on maybe your connection speed. But at this point, at the end of this command, it's waiting for this string in the response. Once the peer has closed this connection, then I know that we're done sending, and I've sent the data successfully. So I set it true. And the last thing I do in this function is I terminate this session that I opened up here. And so theoretically, when I come back through on the next one, there shouldn't be a session open. But again, if there is, because maybe it crashed or one of these returned false or something, I close the session right away. So at this point, we actually went through all of our classes. We talked about the command class. We talked about the file helper class. We talked about the GPS class, the hardware class, the HTTP class. So all these helper classes that encapsulate, a lot of the work we've already talked about, and we've built them up. And now the final thing to do is to look at our main method here. And again, how this functions is the main is more like a functional type program. There's really, and when you look at an Arduino code, there's 2 methods that are called. There's one that's called setup. This is run once, and there's another down here called loop. And in the Arduino code, the loop is run continuously. So it calls loop. Once loop completes, it calls it again, and it just keeps going. So we're going to look at both of these in a second. So at the very top, you can see that I've included, all of the classes that we've built up so far. So this is all about the API, configuring the API, what's the URL, what's the content type, how often I want to send data to the API, and what's the max number of lines that I can send to kind of the API endpoint. Here I'm configuring the GPS cache. How often do I ask for a new point? I'm asking every 5 seconds. This is the last time that I actually requested GPS data. And here's the file name. This is the cache. This is the SD card. If you were to open this up on a computer, you would see a GPS_data.csv file. And this is where I'm storing the GPS data. So this is all about the GPS configuration. So here's where I create my helper classes. So I create the command helper. I'm not in debug mode right now, so I set it to false. I inject that command helper into the constructor for my hardware helper, my GPS helper, and my HTTP helper. And then the file helper, I don't have any, there's nothing that I need for the constructor there. So once I have an instance of all of these helpers, I'm ready to use them in setup and loop. So the first thing I do in setup is I initialize the hardware. I also print out a couple of kind of helpful things here. These are all the URLs that we talked about earlier. So it's kind of in the code too. So if you want to look at Twilio or the wiki or any of those, I put them in there so you can see them. After kind of the basic hardware initialization, remember I'm turning the serial port on. There's not a lot of other stuff done in there. Then I start initializing the different features of the hardware. So here's where I turn the SD card. I initialize the SD card. I turn the module on. So here's where, if this module doesn't turn on, I get a Boolean back saying, hey, this is not on. If it is on, and then I configure the module itself. So, and I'm not tracking whether this thing is configured. Here's, I create some strings so I can see some output of where or what's the status of all this stuff. So then I print the status here. So whether the SD card storage is initialized, I print the status yes or no. Whether the SIM7600 module is on or not, and whether the SIM7600 module is configured or not, I print the status. If for some reason the hardware didn't turn on, so it's the SD card's not ready, the module's not on, or it didn't get configured, at this point there's an infinite while loop and I'm done. So this is, I just console out, I'm halting execution. There's nothing else I can do. There's a part of the board that's not working for some reason. Maybe you don't have an SD card in there. There's no SIM card in there. For whatever reason, something didn't get turned on. This is kind of going to halt the execution of everything. It's just going to stay in this loop. Otherwise, I print out what I found for the manufacturer model and IMEI number. And you can see that. That's all of the setup. And then once the hardware is all ready to go and set up, here's where my loop comes in. And there's really two parts of the loop. Up here is fetching GPS data, and down here is send data to the API. And so let's look at these individually. So I'm just using my helpers. So if I haven't refreshed the GPS in a while, then I use the GPS helper and I go get the current location. If I do get a current location, so this returns true, then I set the GPS refresh time to whatever the current one is. And then I see a misspelling here, so I have to fix that, but I'll do that later. So I have a fresh set of data, and here I'm just kind of logging it so you can see it. And we'll see this in a console out here, so you can see the new point and the new data set. And here's where, because I know I have fresh data, I use the file helper to append the fresh data to the end of the file, so the cache file that I'm using. If for some reason that caching fails, I just log it and said, I failed to cache it. Not much I can do beyond here with this. And the second if statement encapsulates sending data to the API. So if I haven't refreshed within the refresh period, again, this is I think 20 seconds, then what I'm going to do is I strip the number of lines that I can from the top. So the max number of lines I'm going to send is 100. Here's the GPS file. I strip at most 100 lines from the top of that file. And again, that goes through that complex gyration of pulling the 100 lines or 10 lines or whatever it is, and then copying it over without those lines, and then rename or copying it back so I can get the original file back. If I do get some lines from this file, so if the string that I return is greater than 0, I do a trim on it, because sometimes there's a new line character at the end of there. I start to build the content that I'm going to send, and the content is HTTP post format. So what that means is you got some variable name and you set the value. So I'm using the hardware module to put the manufacturer in there. Then the model and the value, and they're separated by ampersands. That's the standard format for HTTP. And then at the very end, I put the IMEI, and then I put the number of the lines here at the end. So it's kind of HTTP post data format, and that I built that content string. And here I use my HTTP post helper, given the URL above. Here's the content I just built up, and my content type is form data. If I do post it, then I just kind of console log, hey, I sent X number of bytes. If for some reason this fails, I use my file helper to append to those. So I'm going to recache those lines, so maybe I can try again later. So I append those to the end. It'll be out of order, but on my web side, I'll be able to manage and handle all of that coming in. But I do append them so I don't lose data. And then I kind of serial or console out, say, hey, I failed to send something, and we added them back to the end. And then I update the last time I sent, or last time I at least tried to send here. The last two things are kind of syncing if you have data coming out of the module and you want to write that to kind of your console out, or if you have data coming in from console out that someone's typed into it, you want to send it to the module. So those are my two helper functions that do that. And then I just wait for a second. So I'm not always hammering this thing. There's at least a 1 second delay. So that's my main loop. And that whole thing is kind of the application that we built. All right, so we just completed reviewing all the code. If we build this code, not expecting any errors, but it does a complete build of everything because I just cleaned it out. And so now I've got a complete build. No errors, no warnings in here, nothing to fix. So I can push this code then to the board. So I push the code to the board. Let's see what it looks like. So I just push it to the board, and now I can see the setup, which is all that's right here. So that's all in the setup. So if I look at the main CPU, kind of size this down a little bit here. Here's in the setup where I have this new start line, which you can see right here, and then the Maduino, and then the extra links. Down here, as you can see, the status of the SD card, the 7600 modules on, gives me the manufacturer, the model, and the IMEI number. And now you start to see GPS points. So this is in my main loop. And so here, this is where the loop is. And if I go and I try to fetch data, if I successfully get it, I write a new GPS point. And that's what you're seeing here. So the new GPS data, and it's caching it to the SD card. And then every once in a while, every 20 seconds to be exact, I wake up and I send the data to the API. And so that's from here. I've sent X number of bytes to the API. And so what you're going to see then is the looping of this is it is set to do one GPS point every 5 seconds. And then it wakes up and it sends the data. And so you're seeing a continuous loop of GPS, and then it sends the API. So you don't have to send it every time. In fact, I think that it's going to be a little drain on the battery to have the LTE radio being that chatty. It's better to kind of bunch this up and package it up and send it in bulk. And that's why it's kind of set up this way, which is I can have a different rate that I sample the GPS and a different rate that I actually send the data to the API. If we take a look at the API endpoint, again, I'm using kind of this webhook site that just it's kind of a generic kind of a test bench that you can send stuff to. Normally, I'm going to send this to my website now. So I'll take this thing and I'll point it at my website and have like an API token so that it's secure and everything's locked down. But for now, this is kind of an open thing that you can use and just send it to this endpoint. And obviously, you would point it to wherever your website is if you're going to do this yourself. But you can see the data that I sent. So see it come in every about 20 seconds or so. A new package will come in. It has the manufacturer, has the model number, has the IMEI number, and it has the lines of GPS data. And this one has, I guess, here's one line, here's 2 lines, 3 lines, and 4 lines. There's 4 lines of GPS data in this one particular packet. I'm providing all of this header data because what I'm planning on doing is these top 2 piece of information is going to tell me how to parse this GPS line. So depending on the hardware, maybe it's formatted differently, but given that different hardware, then I know how to parse my line. This identifier is unique to every piece of hardware. So that's going to really identify kind of which card or which hardware piece that I have. And in my application, I'm going to use that identifier to kind of tag that to a particular asset that I'm tracking. Maybe it's card number 1 has this IMEI, and so then when I get the data from all these different cards that are coming in, I know that card number 1, this IMEI, is at this location. Here's the history, and I can start to track all those points and plot them out. As always, if you like this kind of content, like and subscribe. If you have any questions, leave a comment below and I'll get back at you.